A microcontroller is an integrated circuit fabricated on a semiconductor chip that performs operations related to acquisition and processing of data, controlling a system, and monitoring its status. In comparison to its enormous processing power, size is much smaller, hence the name micro. Microcontroller is just one particular variety of processors available in the domain of embedded system. All the processors can be grouped into three categories, namely general purpose processors, bit slice processors, and special purpose processors. The design, development, and application of each category have different objectives. General purpose processors, often termed as GPP, are the microprocessors in true sense. Surrounding the microprocessor, various semiconductor chips are placed and connected to make the microprocessor fully functional. Hence, GPP is an open-ended processor. As an example, a typical microprocessor board contains supporting ICs like 8253 or equivalent, acting as a programmable timer, 8255 or equivalent, acting as a programmable peripheral interface, 8257 or equivalent as a DMA controller, 8259 or equivalent as a programmable interrupt controller, and many more. A bit slice processor is a combination of hardware slices. The slices are integrated step by step to augment functionality of the existing system. This is something like adding digits to phone number to expand the volume of its usage. Special purpose processors, on the other hand, are processors of different class. Their hardware are equipped with special functionalities that are normally not present in a GPP. Digital signal processor, often called as DSP processor, is an example of this type. A DSP processor is used to perform computation-intensive job in the area of signal processing. Its hardware contains the feature of multiply and accumulate called MAC operation, which can be triggered to execute convolution lightning fast. The recent processors of this kind contains the dedicated hardware block for performing discrete cosine transform DCT. Microcontroller is the second example of a special purpose processor. It is equipped with special hardwares like PWM, the pulse width modulator, ADC, the analog to digital converter, PLL, the phase lock loop, etc. One group of microcontrollers contains functionalities of one type only. In order to switch to different features, we need to select microcontrollers from appropriate group. The application of microcontroller in our daily life is omnipresent. The choice of a microcontroller is a tricky game sometimes. Speed is one of the important aspects of a microcontroller. Higher the speed or clock frequency, it is expected that faster will be the execution of instructions. Different functional blocks of a microcontroller usually run at different speed. For example, the conversion time of ADC is less than the time period of clock by a certain factor. A microcontroller IC is equipped with built-in memory. The external memory, however, may be connected also. Obviously, the internal memory is fast and cost-effective but less flexible in terms of size and features. The memory can be categorized as a program memory or code memory and a data memory. The former is used to store instructions, whereas the latter stores data. The memory can be volatile or non-volatile. The volatile memory loses all its content when power is off, but it is fast. The non-volatile memory keeps data intact. The memory handles data mostly in a parallel fashion. That is, all the bits of a particular byte are accessed simultaneously. But in smaller applications, sometimes the data are accessed bit by bit basis. The memory therefore is serial and internal. The input-output pins, called I/O pins, is limited in number for microcontroller of reduced version. This is used in smaller applications. The full version of the IC contains all the I/O pins. The developer has to select the required version for a particular development job. The developer has to identify the particular function required in an application and accordingly has to select the right type of microcontroller. The feature can be either a particular hardware block or a particular communication protocol supported. The next basis of selection is its power consumption. Whether the application runs continuously or intermittently is a matter of concern. Reduction of energy bill by reducing power consumption is an important aspect for continuous run. Nowadays, the operating voltage is reduced progressively as the power consumption is proportional to the square of operating voltage. For this reason, the voltage reduces from TTL compatible 5 volt to CMOS level of 3.3 volt, 2.5 volt, etc. A microcontroller can stay in active mode or sleep mode. The power consumption in sleep mode is minimal, so when intervention of microcontroller is not required in a process, microcontroller can be programmed to stay in sleep mode to reduce power consumption. For fitting the IC into a given board, attention needs to be paid to the available package of IC. Some IC can come in different forms of packages. It is therefore a criterion for selection. The overall cost of development is the feather on top for selection of a particular microcontroller. A microcontroller with enriched features requires more attention and knowledge from developer, but it brings about less development time. The appropriate trade-off is the demand of the day. In today's world, microcontrollers are the hearts of embedded systems.